achievements in chronological order 1992-96. Year description impact. 1992-93 consolidation of businesses and disposing of dealerships in Shaival, Jang, Okara, and Bahawalnagar. Organized operational management. 1994 Ford Agricultural Division sold to Fiat Italy. As a consequence, Ford Tractor Assembly was discontinued worldwide. The market suffered the loss of a highly reliable product essential for efficient farm operations. 1994 obtained a license to manufacture Ursus tractors, which are MF-designed tractors made in Poland provided cost-effective tractors. 1994-96 assisted the government of Pakistan in initiatives related to the farm sector, especially delinking prices of farm produce from government-owned corporations for free float and, as a result, linking them with international markets. Until this point, only government corporations could export agricultural commodities. Some of the steps taken by the committee formed by Prime Minister Benazir Bhutto. Agricultural commodities prices were controlled by the government through the Agricultural Price Commission. Agricultural commodities were traded by government corporations, i.e., cotton by Cotton Trading Corp., rice by Rice Export Corp., wheat by Pasco, and provincial food developments. If the price for a pound of cotton lent in the international market was 70 cents, the local price would be below 25 cents. Farmers' margins were so thin that they were surviving by reducing living standards or moving to spaces other than agricultural production. On the recommendations of the committee, the Agricultural Price Commission was abolished, and prices were automatically linked with international markets. While produce prices were assured to fetch international prices, a program to reduce the cost of production was taken into account. 2 steps were taken. Multinational companies had a monopoly over agrochemicals. The committee decided to break this monopoly by using generic names for all agrochemicals. Locally assembled tractors were of low quality and at higher prices due to the monopoly of the assemblers. The import of tractors was allowed to introduce some competition. Seed cotton prices surged from 400 rupees to 1,600 rupees per 40 kilograms mound overnight. A similar situation unfolded for other commodities. Consequently, crop production became profitable, and land lease prices skyrocketed. However, we couldn't capitalize on the benefits of lower production costs when selling at international prices due to a change in the government. A program was going to be implemented to manage production, substitute imports, and generate exportable surpluses to balance trade deficits. Prices of agrochemicals dropped by at least 70%. Under the Awami tractor scheme, over 30,000 European standard tractors were imported and delivered to small farmers at almost 50% less than the price of locally assembled tractors. Interventions and achievements in chronological order 1995 to 2002. Year description impact. 1995 While traveling from Houston to El Paso, we noticed a cotton research farm alongside the highway. Curious, we decided to visit. The farm manager graciously showed us around the cotton fields. During our tour, while standing in a particular cotton field, the manager mentioned that they had developed a variety resistant to bollworms. We appreciated their work and continued on our journey. Our curiosity led us to further research. We discovered that bollworm-resistant seeds were available for testing by selected farmers in the U.S. We requested one of our associates to arrange 20 kilograms of these seeds. We distributed them among several farmers in the Pakpatan area for testing. The results were promising, the seed performed well, and the growers shared it with others. This variety quickly spread, transforming the landscape of cotton production. Our quest for knowledge continued. We delved into the technology behind this remarkable development. It was revealed that Bt, a soil-borne bacterium, produces a protein toxic to young larvae, provided the soil system allows the microbes to survive. Armed with this understanding, we studied natural habitats to identify any shortcomings in our conventional industrial production system. In the following pages, we will share the details of these developments. This intervention was implemented when the cotton crop faced severe damage from bollworms. It played a crucial role in helping farmers sustain their crops and significantly boosted the textile economy. This marked our second significant contribution to cotton production. Previously, We introduced Delta pine cotton seeds in 1974. By identifying and propagating these seeds, we empowered farmers to produce cotton profitably. This not only benefited the textile industry but also had a positive impact on our national economy. Thanks to these seeds, farmers were able to cultivate cotton successfully, contributing to the overall prosperity of our country. This seed is famously known as BT, which stands for genetically modified cottonseed. However, after a few years, bollworms, especially the pink bollworm, developed resistance, causing heavy crop damage. It was during this crisis that PQNK emerged as a rescue. 1997 became national distributors of Kenwood Japan and introduced audio systems to car assembly units and the public, supported local car manufacturing and facilitated technology transfer. 2000 established an assembly plant for air conditioners and home appliances under the brand name Kentax, promoted energy-efficient systems, technology transfer, and skills. 2002 became strategic partners of Altitude Software and introduced call/contact centers for telco, banks, online businesses, payments, distant education, and healthcare, contributed to public services. Adversity, Conceptualization and New Beginning 2002-08. Year description. Impact 2002-06. The world is governed by the New World Order, carefully designed and effectively implemented. Challenging capital operators is not tolerated. We engaged in activities that attracted attention. State tyranny took action, halting our business operations and imprisoning me for nearly 4 years without any charges, on actions of their own. This is what they do to those who deliver and contribute to overall well-being. I feel honored and proud to have withstood oppression and tyranny whilst serving my fellow farming community. Development work came to a halt, work in progress was lost, and so was the technical and financial support to the farmers. The positive aspect of the setback was that I utilized my time productively and conceived nature-based production processes that will change the food production system as we know it. 2002-06 Conceptualization, the discovery of Bt bacteria, natural guardians that protect plants from caterpillars, sparked my fascination with the intricate balance of natural ecosystems. Driven by a desire to safeguard the environment and the resources that sustain life, I embarked on a deeper exploration of this realm, culminating in the development of PQNK. 2007 New Beginning, after a 4-year suspension, during which we lost new business acumen, resources, and reliable connections, embarking on a new beginning was no easy feat. Social biases created resistance, as credibility emerged as the most crucial feature for legitimate and respectful progress in life. In essence, our new beginning transcended mere resumption. It was about transforming the trajectory of progress rooted in resilience and wisdom. Our start was indeed humble, yet our intrinsic abilities played a crucial role. We meticulously outlined a clear path, refining it to adapt to new realities and harness our newly acquired strengths. This transformative journey was guided by the profound realization of the inherent strength within natural algorithms and deep thinking during my confinement. In essence, our new beginning transcended mere resumption. It was about revolutionizing the food supply chain, rooted in the wisdom of the natural ecosystem. 2007-08 we held a valid license to assemble, manufacture, and market Ursus-branded tractors in Pakistan and beyond. To spearhead this endeavor and facilitate the transformation of farm machinery, we established a new company called Farm All Technology. Its mission extended beyond machinery as it served as a hub for disseminating knowledge on production agriculture. We meticulously crafted and introduced 3 models of tractors, ensuring they adhered to the highest quality standards. Additionally, we established a separate internal setup to create a new generation of machines, aligning them with our evolving understanding of production agriculture. Interventions and achievements in chronological order 2007-08. Year description. Impact 2007 The introduction of solar irrigation, drinking water systems and household electrification made a profound impact, especially in ensuring year-round food production. Here's why it mattered. Water security. By harnessing solar energy, we provided a reliable water supply for irrigation. This stability allowed farmers to cultivate crops throughout the year, reducing dependence on seasonal rainfall. Food self-sufficiency. consistent water availability translated into increased agricultural productivity. Farmers could grow multiple crops, enhance yields, and contribute to local food security. Economic resilience. Solar-powered water systems mitigated the risks posed by unreliable electricity. Farmers no longer faced disruptions due to power outages, ensuring a steady income from their produce. Community well-being. Access to clean drinking water improved overall health and well-being. It also empowered communities by reducing the burden of fetching water from distant sources. In essence, this intervention wasn't just about technology, it was about sustenance, resilience, and progress for generations to come. Household electrification. Beyond irrigation and drinking water, these solar systems also electrified households. Families gained access to clean and sustainable energy for lighting, cooking, and powering essential appliances. This transformation improved their quality of life and fostered economic activities within the community. The implementation of solar systems in remote areas had several transformative effects. First, it provided an alternative energy source, reducing dependence on conventional electricity. Second, clean water became more accessible for both irrigation and household needs, liberating many households from feudal control. Third, the initiative promoted liberty and sustainability, ensuring long-term access to essential resources. Fourth, increased water availability led to improved farm productivity, benefiting livelihoods. Finally, beyond water, these solar systems electrified households, illuminating homes and powering essential appliances. Solar water pumping systems were installed in Khalistan, first time ever. 2008. Our journey marked the transformation of agricultural production systems, aligning them with the natural algorithms governing vegetation, soil fertility, and plant protection. This shift aimed to restore ecosystems that had suffered degradation due to practices that, ironically, were labeled conventional and industrial. Our destination, the Amazon forests, a timeless marvel with ancient roots stretching back through millennia. As we explored, our eyes widened in awe. Thriving vegetation, undeterred by the passage of millions of years, flourished without depleting precious resources. May the Amazon's resilience inspire us to tread lightly upon this earth. We discovered that 4 practices in our agricultural production process are detrimental to the natural ecosystem. Soil inundation with water. Soil disturbance through tillage. Keeping soil bare without the cover of organic mulch. Unicropping, which restricts biodiversity. Revolutionizing rice cultivation for a sustainable future. 2008. Description impact. Persuading the understanding reached on the study of natural habitat and ecosystem in the Amazon, we decided to take on the most challenging, rice crop, as our first adaptation. We adopted a step-by-step approach and chose to grow rice in moist soil rather than inundated soil. After leveling a 44-acre field, we created raised beds and broke the hardpan. Transplanting 2-week-old seedlings into hot, dry soil posed a challenge. To address this, we designed a dry soil transplanter capable of punching holes and filling them with water, whilst our team carefully placed seedlings in each water-filled pit. We followed the spacing recommendations of the System of Rice Intensification, SRI, promoted by Cornell University. The experiment was successful. Our next challenge was weed management. Conventional solutions involve inundated soil combined with herbicides, but this approach did not align with our vision. Instead, we designed a precision weeder and aerator. The process worked exceptionally well, allowing us to save at least 70% of water and other inputs, including labor. This marked the first step toward our consolidated natural approach, which we initially named Paradoxical Agriculture, PA. Later, we renamed it PQNK, pronounced as picnic, standing for Paedar Qudratti Nizam Kashatqari, which means a sustainable natural farming system. We presented this technology at the International Rice Congress held in Hanoi in 2011. Today, it is being adopted by countries such as Israel, Korea, China, and many others. The technology showcased here revolutionizes rice cultivation by significantly reducing water consumption through our moist soil method. Precision weeding and aeration techniques, devoid of herbicides, enhance sustainability and soil health. PQNK epitomizes sustainable natural farming, fostering a greener and resilient future, showcasing how innovation harmonizes with nature for widespread adoption. As process matured, weeder is replaced by organic mulch and transplanter with precision no-till planter. Now process is shifted DSR. Successful production of rice on raised beds in moist soil revealed our ignorances towards sustainable food production, 2008. Year/subject description. 2008 Understanding the natural algorithms of soil fertility, plant propagation, plant protection, and water supply arrangements is mind-boggling. Especially when we realize that this sustained over 1.5 million life forms for at least 400 million years without depleting any resources. It makes one think about our ignorance, the towing augmentation of the tillage-based production system which initiated some 10,000 years ago by the Homo sapiens, presently seemingly driven by financial motivation rather than by the wish for sustainability and provision of nutrient-dense food at an affordable cost. Agriculture is a vast and complex field. The purpose of this document is not to provide comprehensive education. Instead, it aims to list our interventions and contributions to the sector that have demonstrated a significant impact. Some of the algorithms are listed below to enhance general awareness and to motivate researchers in adoption of innovative thinking for a brighter future. The natural ecosystem is robust. Plants don't require any human intervention to grow and produce well. Extensive experimentation has been done during the past 15 years. Hundreds of thousands of farmers are benefiting from PQNK, a sustainable natural farming system. Our work is open source and, as such, placed on YouTube in all formats: speech, text, video. As we are self-funded and a non-commercial entity, we spend limited resources on fancy stuff and keep focused on RAND. New scientific understandings are listed below, which resulted in huge following, benefiting farmers across the world. PQNK, the natural production system. The soil and the atmosphere contain everything necessary for food production to sustain all inhabitants. Water serves as a carrier of minerals and helps plants maintain a moderate temperature, whilst sunlight acts as the driving force. The natural water supply system comprises rain, dew, and humidity. They provide sufficient moisture for crop growth everywhere without the need for irrigation. The soil contains all the essential minerals in insoluble form, but microbes render them soluble based on plants' requirements. Biology takes over from chemistry, creating an environment conducive to the flourishing of plants. Soil, in no case, should be inundated because that drowns soil life. Various species of Bt bacteria in the soil protect plants, with each type targeting a different set of insects. Tillage, the disturbance of soil, disrupts the ecosystem and contributes to the issues faced by industrial agricultural. Weeds thrive in areas where the soil is compacted, leading to reduced water absorption capacity, or where the soil is left exposed. Weed roots play a crucial role in aerating the soil, nourishing microbes, and maintaining soil temperature with its foliage. They don't compete with plants for the minerals in the soil, as they are present in abundance. By adhering to the natural production system named PQNK, which requires no purchased inputs, we can achieve abundant nutrition-dense food. This approach is essential for regeneration and sustainability, providing the only viable option for ensuring a resilient future.